Hey there. In this video, we are going to start talking about classes in C++, beginning with talking about objects and a simpler kind, which are structures. So in our first exercise, we're going to make a person structure that has a number of different attributes. These are member variables. They're variables that belong to this structure. We're going to see what happens if we try to output a person. Turns out it's probably not going to work the way we want to, but let's give it a shot. So let me take these notes here. So here is our exercise, and let's give it a shot. So if we want to make a structure, we're going to need to say struct. We're going to call it person, and our person is going to have a string, so we need to include string, first name, string last name, int age, because their age is going to be a number of years, presumably. Is employed is going to be either yes or no, so we'll make that a Boolean, is employed. And Boolean is student. Okay, so here's a little structure that we've made. Now let's see if we can actually make a person. I don't think we'll need to wait till the next exercise to do that. Let's just give it a shot now. So I want to make a person named Mike, and we can try to output Mike. I don't think he'll be very happy about this, but we'll give it a shot. Ooh, no match for operator arrow. And so why is this complaining it to me? Basically right now there's no way for C++ to understand what it means to print out a person. I built this structure just now, and it is going to keep in data in memory in the computer a bunch of space allocated for Mike to have a first name, a last name, an age, whether or not they're employed, whether or not they're a student, but there's no instructions on how you would print that. What does it mean to print a person? I haven't described that behavior at all. So these two arrows don't really work too well. There is another print function. I don't think it will work too well, but I'll give it a shot. The function is called printf. And you can see it goes into orange because it's a built-into C++ function. And I can try to print f Mike, but I think I'm going to get a very similar error. Yeah, cannot convert person to const char char, meaning that printf is trying to print a string. A person is not a string, so you can't do that. So we're going to have to think about ways that we're going to handle, if we have this big chunk of data in here, how do we see it? How do we know that it actually is there? Now, out of curiosity, let's see what happens if I put this into Python Tutor. I'm kind of curious to see how it will represent my information. Let's go to C++, throw in my code, give it a shot. Oh, look at that, kind of interesting. So, nothing really happens here because person here just, makes the object and nothing actually happens. But you can see in here is the block of memory used to allocate all the information for a person. So there's an integer spot for someone to put their age in. There is a Boolean spot for someone to put is employed. There's a Boolean spot for someone to put is student. These ugly looking things we saw before were because we have strings here. We can make that a little bit nicer by doing character arrays instead, which will then give us pointers. So you can see it's a little nicer now. We get actual pointers for that. Might leave them as strings. We'll see how the next exercises go. But importantly, what we see here is person is an object. So this is where we get into this concept called object-oriented programming. And it's the reason that C++ is actually the language that is covered in this course. There are a number of different languages out there that use object-oriented programming, including C++, Java, Python, I believe JavaScript as well. Many of what we would call higher level programming languages, that is ones that don't give instructions directly to the computer to manipulate where does one bit go from another one, or where does a memory register in the computer need to access something. Anything that allows us to just program using words is what you could call higher level coding language. And so Many of these languages like to represent big chunks of data, things that all mean something together, as objects. For instance, if I want data that represents the information about a person, I might make a person object. And the person object has a name, has two names, has their age, has information about their employment status or their student status, all kinds of stuff you could associate with a person. And all of this is kept into a big chunk of memory in your computer, which is all associated with this label, in this case Mike, because I called it that. And I can declare more people if I want to. It'll just allocate space for all of them. And this is super, super helpful because it means, for instance, that if we want to be able to link some of these pieces of information together, I don't have to have a million different variables with related names or something. I can just have one object called me that has all of the different pieces of data I'm interested in. So this is our first structure. Let's see if we can play around a little bit and do some other things in our next exercise. So in the next exercise, we're going to write a function that takes 5 parameters and returns a person. Those 5 parameters presumably are going to go into our different attributes. Then we're going to call this function from the main function and print out each attribute one at a time. So, okay, we're going to write a function that's going to take 5 parameters and return a person. So I think we're gonna stick with using strings here. And now I need a function that's going to create a person. So the return type for my function is a person. This is going to be, make person, I suppose, is a fine name. And we're going to need a string first name, string last name, string age, int age, and it's a number, Boolean employed, and Boolean student. Okay, it's a lot of parameters, but we're going to need to have all of these things together. So first off, we need to make a new person P, just for fun. And now we need to assign each of these attributes to be the value we got from our parameters. So for instance, if I want to access P's first name, I can say P.firstname. And I want to assign this something. What do I want to assign it? I want to assign it the first name I got from my parameter here. Now, I also want to do P.lastname. It's going to be the last name I got in my parameter. P.age. It's going to be the age. Now, note that these have the same name, but because this one is right after P dot, it knows that this refers to this. It's referring to specifically the property of my person P when I write P.age. This age here is not that. It's a different age. It's the one that comes directly from my parameter because I don't have something that links it to the object. So even though these seem like they have the same name, it turns out that these are actually going to refer to different places in memory. And you'll note that in the future, you're going to see a lot of times where you'll have object dot a variable name equals the same thing, the same word. But they refer to two different things. One refers to the memory associated with the object. One refers to, in this case, the parameter that I'm getting to build it. P dot is employed. It's going to be employed. And P dot student, student. And I'll return P. So this whole thing should make my person. Now let's make sure it actually works. So I'm going to have person Mike equals make person. And now this function should return a person that I can then assign to Mike. So let's give it all the variables it needs. It needs a first name, last name, age, employed true, student false. Now let's make sure it actually worked. So I'm going to print out person Mike, and we'll print out Mike dot first name dot last name, age is employed is student. Let's see what happens. Oh, I made a mistake. Oh yes, I put student, but this should be is student. Let's fix that. Okay. And what do we get? Well, it prints out person Mike. It's got my name, my last name, age, 1 and 0, referring here to true and false respectively. If you wanted to actually say true or false, you can do the trick that we saw before, which is using the question mark operator, say if employed, then true, otherwise false. Oh, sorry, this should all be in parentheses. There we go, and it converts to true. You can do the same thing, perhaps as practice for is student. And yeah, there's 0, which is the correct answer. So there we go. We've made a function that returns a person. Note that inside of our function, we had to construct that person, and then we're going to return it at the end. And that value was assigned to the person I created inside my main function. So make person here, created a person, passed it over to Mike, and then gave me all this information here. Now, out of curiosity, let's see what happens. Will this still work if I use a character pointer for the strings? I'm not certain. Let's give it a shot. So character pointer, character pointer, character pointer. Everything else should stay the same. Code still seems to work okay. I got some warnings. It's not very happy about it. But it seems like it worked okay. Now, out of curiosity, what if I take this and put it into Python Tutor? Will I be able to see all of this happening? Let's find out. Okay, well, there's space for a person. I need to get that person. So I'm going to go into my make person function, and it's going to have a character pointer that points to my name as a string, but this is an array of characters. My last name as well. And then age, employed, and student. And what's going to happen is we're going to build a new person. Or actually, oh, it looks like it actually is kind of shortcutting the process here. You'll note that it's actually taking the person that it was going to assign to later, Mike, and it's starting to assign all of these pointers and values to the original object. So kind of convenient for us actually. Since that's what's going to end up happening at the end of the day. And so then by the time I return, this part of the code goes away because we don't need it anymore, and we're left with this information for Mike. So kind of neat. I thought it might actually make a separate person for P, but it looks like C++ is smart enough to realize that since this person is going to be assigned to Mike later, it shortcuts the process and says, you know what, well, if Mike is going to turn into the person that we're making, let's just start assigning all of the variables right away. Not the thing I expected it to do, but you know, it's good to know about that kind of stuff, I suppose, because this is something that could make a difference later down the line. Okay, that was our second exercise. Let's move on to the third one. So, third exercise. Continuing on, make a pointer that points to a person and try doing something like pointer.age and use the error message from the compiler to see how to access a variable directly without using an asterisk. Okay, let's give that a shot. So, in our code, we have myself, and let's make a pointer to me. So we'll say a person pointer takes the address of me. So this pointer should be pointing to me now. And then what happens if I try to do print, say, pointer dot first name? Now I believe this will give me an error. So warnings, and then it does. And let's take a look at this error and see what it says. Request for member first name in pointer, which is of pointer type person star. Maybe you meant to use this. What is this? Well, since pointer doesn't actually hold the information for a person object, you can't do pointer dot first name because a pointer doesn't have a first name. It just has an address in memory of where you can find Mike. Now, what if you wanted to follow that pointer and get the first name? Well, one thing you could think of doing was wrap pointer in parentheses and then do, at pointer dot first name, and then you get Michael at the end, which is what we want. But it turns out there's actually a quicker way to do it, which is rather than using these parentheses or using this dot, we actually just make an arrow. This makes a lot of sense. You take pointer, you follow the arrow to get there, and then you grab the first name. And look at that, it does exactly what we want. Just so we can see this in Python tutor again so we can kind of see what is going on. Let's run this again with our new code. So I build myself. I make my pointer point to, and note what it's doing here is it's pointing to the first name, which seems kind of weird, right? Why is it doing that? Well, if you think about it, this object is just taking up a big block in memory, probably a block that's all adjacent to each other. It's all consecutive, which means that, first off, because I've declared person to be a structure, C++ now knows exactly how much data is needed to store a person. You need enough for this pointer, this int, this boolean, and this boolean. So there's a fixed amount of space that you can possibly need for a person. Because we know exactly what order all the data appears in, a pointer that points to a person object only needs to point to where it starts. And in this case, where it starts is with the first name. Now, you can't do the pointer arithmetic we were doing before with a simple array type and just say, pointer +1 and hope to get the last name. Not really going to work too well. But anytime that you need to take the pointer and then, for instance, get the age, you can use the little trick that we just discovered, which is to use the name pointer, then literally an arrow, a dash, and a greater than sign, and then the variable that you're looking for. And in this case, that will print out the first name. Michael, just like that. Okay, so that was our third exercise, and let's move on to the last one. Okay, so now into classes. So we made this a structure, but we want to have a class to represent a person, and the person that way can actually have functions associated specifically with that class. So we're going to make the person structure a person class. We're going to add a member function that sets the person to be unemployed if their age is below 16 or above 65. So let's give that a shot. So first we're going to make this into a class person. All this stays the same, but we also want to have a function that sets the person to be unemployed if they're too young or too old. So now, this is just going to change an attribute for our person. It's not going to return anything because all it's supposed to do is modify one of these values for our object. So if we want to modify something but we don't want to actually return anything, we can make this a void. And we can say this function's called something like, I don't know, unemploy. Does it need any parameters? No. We just run this function, and then it checks to see what our age is and uses that to determine if we should be employed. If the age is less than... And now, here's the thing that to be careful of, is when I say age, does it know what age is? Now, if I'm not mistaken, I may need to do something different and not just write age. But I'll leave it for now and see what kind of error C++ complains at me about. If my age is less than 16, or my age is greater than 64, is it 64 or 65? Above 65. So greater than 65, then is employed should be false. And that's it. Okay, now here's this I believe can actually stay the same. This function which creates a person, even though this is now a class instead of a structure, still works just as fine. And in fact, I think all the rest of this code works perfectly well. The real question is, will this compile? And the answer is no. And what is the error? Char star person : first name is private within this context. Well, that's an issue that we have to figure out what to deal with right away, which is that right now, because of how I declared my person, the default is that none of these things can be accessed the same way they can be accessed with a structure. In fact, I should actually specify, if I don't, that there's a special thing you have to write to prevent that from happening. Looks like my notes don't actually have this, although I should write something about that. Maybe what we'll do is we will put in one little example in here, so just so that we can see what that looks like. Yeah, okay. Here's what we'll do. Let's grab our structure here. We're modifying lecture slides in the middle of the video. Unbelievable. Okay. So this is going to be a class example. Strip away all of the notes, and we're just going to have a class example, which is going to be our employee. It's going to be a class. Push this down to the bottom. And now here's the thing you have to write in, which is public. Small p. Let's color this nicely. Yeah, that'll do. And to explain what's going on here, how should I put it into short? What I want to say is that public here is necessary so that the rest of your program can access these variables. For let me stretch this out a little bit. Yeah, and we'll put this into is a good, no, it's not bright enough. There we go. So it doesn't look a lot different from a structure, but we do need that public keyword, because if we don't write public in here, then you can't actually access. And so notice everywhere it says private, that's a problem. So we actually need to just write public and have all this stuff in. Okay, now everything runs okay, which is good. Now here's the question is, so I am employed, and this won't change anything, but if suddenly I rapidly age and become 67 years old, will something change about my employment status? So right now, if I run this, it says my employment is true. What if I run my new function? So to run my new function, I'm going to do Mike.unemploy. No parameters, and I don't have to assign this to anything, so I can just hit the function and see what happens. And look at that, it seems to have changed it perfectly well. So the age here corresponds to this age here, and the reason that it's going to be able to do so is because this function is declared within this class. Pay very close attention to where these braces are. So there's one here, which closes down here. This is for this function. This is for if statement. Since this function is declared within the class, it knows any of the variables that it can see right here. Also, because these are public, anybody can access them if they really need to. And later, and I think in the next lecture, we'll see about the difference between public and private. But for now, we need to have this just so that otherwise, we can't actually get the first name, last name, and so on. But we now have a class. It's a person. We have a function that we can run from the class. If we want to run a function from a class, we need to do kind of the same thing we did with our string methods, which is the name of the variable, in this case Mike, dot the name of the function you want to run. And so we run the function after creating our person who was originally employed and too old. Running the unemployed function changed their employment status from true to false. And there we have it. So my suggestion is definitely to give lots and lots of time to try out things with classes. There's really no limit. I guess the only limit is your imagination with regards to what sorts of objects you can think of, and try programming these things. Consider in your mind, what's something that you find kind of interesting. See if you can code something equivalent. For instance, I like board games. Maybe I could think about making a board game class. What sorts of attributes, what sorts of variables would I have inside of it? What sorts of functions would I have in it? Probably would have a variable that keeps track of, who is the first player, and I might have a function that says determine first player, and then it would assign that to be a certain person. Maybe I even have a class that has another class inside of it. For instance, my board game class might have player 1 being a person, player 2 being another person. And so, you can mix and match all these things as much as you like. And really the best way to get comfortable with it is for you to kind of play around and see what happens. So that I think wraps up this video. Definitely give some time to try some of this stuff out. I think it'll be worth your time, especially since this is really the foundation of what is going to be the main theme of the next programming workshop course. In CSCI 1061, we're going to be doing classes basically from day one. So you want to be very comfortable with this, not just so that you can do well in the next labs and the final test, but also because this is something that you're going to be seeing nonstop throughout your programming career. So it's going to be very comfortable with it because it's going to matter a lot. So that's it. Thanks for watching, and I'll see you guys later.